Hi everybody, it's Miss Moncrief again. I'm back with another topic. Today we're going to be learning about the Pythagorean Theorem. We started this topic the last time. We learned the intro to it, how to set up the right triangle, what A, B, and C are. Today we're going to use what we learned last class to be able to solve word problems, okay? So today's lesson objective is students will be able to solve real-world problems involving the Pythagorean Theorem, okay? And from last time, we should know that the formula for Pythagorean theorem is a squared plus b squared equals c squared. You want to have that in your journal if you don't already. So like I said, today we're going to be solving word problems. We're going to have to use our steps. Step 1 is to have the diagram. Step 2 is to label A, B, C, and D. Step 3 is to write your formula. Step 4 is substitute. And step 5, solve. Okay? Now we're going to start simple. On this first one, they gave us a diagram, but let's read. It says a 20-foot ladder is placed against the building to reach a window that is 16 feet above the ground. How many feet away from the building is the bottom of the ladder? All right, so like I said, they gave us a diagram, but let's talk about the diagram because next time we're going to have to draw it. So we know we have a ladder. You know when you're leaning a ladder, it's slanted, okay? So they drew right here the slanted side. That's the ladder, and they say in the problem that the ladder is 20 feet. So that's where that 20 comes from right there, okay? It says it's reaching a window. The window's on the wall, and the window is 16 feet above the ground. 16 feet above the ground. So when we draw the wall, it's going to reach a total height of 16 feet above the ground. That's where that comes from. And we're solving for how far away from the building is the bottom of the ladder. That's the question. How far away from the building is the bottom of the ladder? So we're looking for this length right here. We don't know it, okay? Step 2, label A, B, C, and D. Okay, so let me get a different color here. A, well, we always start with C first. C is the longest side, C is the slanted side. So my C is going to be 20. My shortest side is my A, so my A is going to be down here at the bottom. That's my unknown, and the leftover is B. Step 3, formula. A squared plus B squared equals C squared. Step 4, substitute. I'm going to replace A with, I'm going to just use A. I'm going to replace B with 16 and square it. And I'm going to replace C with 20 and square it. Bring down your plus sign, bring down your equal sign. Now we're going to put this in our equation solver, Math Papa. Granted, we set it up right and we type it in right, we will get the correct answer, okay? And the answer for this one, let me do the first one with you. Here we are. A squared plus 16 squared equals 20 squared. A squared plus 16 squared equals 20 squared. Hit calculate it. It gives us A equals 12 or negative 12. Remember, we do not use the negative because we're talking about length, and length has to be a positive value. So my answer is going to be A equals 12. That means that the ladder must be 12 feet away from the bottom of the building. This is the word problem, so think about it in context of the word problem. Does that make sense? It does. That's my answer. Example 2, a 10-foot ladder is placed against the building. The base of the ladder is 6 feet away from the building. How high does the ladder reach on the building? Now, it may be hard for you to draw the pictures. It kind of was for me at first. So I just drew a right triangle because I know that's what I'm working with. And then I kind of put the pieces on the triangle. So again, we're talking about a ladder, a 10-foot ladder. So I know my ladder is the slanted side. My ladder goes right here. That's going to be 10. The base of the ladder, here's the base of the ladder, is 6 feet away from the building. So this distance here, the distance the ladder is from the building is 6 feet. So I'm going to put a 6 here. How high does the ladder reach on the building? This is the building here, like that's the little house, that's the little door, it got some windows. We're looking for this length right here, okay? We're searching for the height of the building right there. So step 2, label my ABCs. C first, C is a slanted one, that's my C. The shortest one is my A. The leftover one is my B. Step 3, formula, A squared plus B squared equals C squared. My A is 6, square it, plus my B is unknown, I'm gonna use B, square it, equals my C is 10, square it. Put this in Math Papa and get a value for B. And it's gonna give me 8 feet. B equals 8 feet. So the ladder reaches 8 feet up the side of the building. Okay, next example. 2 hikers leave a cabin at the same time. One heading due south and the other headed due west. So they're going south and they're going west. Okay. After 1 hour, the hiker walking south has covered 2.8 miles. So the one going south has covered 2.8 miles. And the hiker going west has covered 3.1 miles, west 3.1 miles. At that moment, what is the shortest distance between the 2 hikers? So the shortest distance is always the diagonal, okay? Because, for example, if I'm right here and I'm walking this way, and you were with me and you're walking this way, the shortest distance is this diagonal distance here, okay? It's going to be shorter than if I go down the street, cross over, come back down and walk. Like that's a lot of distance to cover. Whereas if you go diagonally, that's always the shortest distance. So when they say the shortest distance, they're talking about the diagonal. That's just something you need to remember. Intuitively, it makes sense. If you draw it out, it makes sense, okay? So on this one, I put a visual representation for you so you can understand south, north, east, west, just in case that's confusing for you. But on the quizzes you do later, it won't have it. So again, north is up, south is down, west is to the left, and east is to the right, okay? So we start at the cabin. The cabin is right here. One hiker went west, 3.1. That's where this distance comes from right here. The other one went south, which we would draw going down 2.3 miles. That's that distance right there, okay? So now we have our diagram. Let's do A, B, and C. C is the diagonal, and A is the shortest one, which would be right here, and B is the leftover, which would be right there. Step 3, formula. A squared plus B squared equals C squared. I'm going to change my A to 2.3 and I will square it. I'm going to change my B to 3.1 and square it. My C is unknown. I will leave it as C and square it. Bring down the plus sign, bring down the equal sign. We have 2.3 squared plus 3.1 squared equals C squared. We are going to put this in Math Papa, okay? And it's going to give us C equals 3.7 miles. So at that particular moment, after 1 hour, the shortest distance between the 2 hikers is 3.7 miles. Next example, this one's about a soccer field. It has no picture, so we're gonna have to draw one, so pay close attention. A soccer field is a rectangle. It is 90 meters wide and 120 meters long. The coach asks players to run from one corner to the other diagonally across. How far is this distance? Okay, so what shape is a soccer field? The soccer field is a rectangle. I'm going to draw a rectangle. That's the best I could do. Okay, it's 90 meters wide, how wide you are, 90 meters. So I'm gonna put 90 right there, and it's 120 meters long, 120. This looks odd, I drew it kind of weird, but hey, it's just a drawing, it's not drawn to scale. So let's just leave it alone. And now the coach wants to know how far is the diagonal distance across. If you run from one corner to the next corner, how far is it? Okay. So we broke a rectangle down to 2 triangles. You don't need to use both of them. So I'm gonna just highlight one of them, and that's the one I'm gonna use. I'm gonna highlight this bottom one right here. So even though it's a rectangle, we're still working with right triangles. We only need half of the shape, okay? Now I know the bottom of that shape is labeled 90, but there's no number here. Okay, there's no number there. But if this side is 120 and this is the rectangle, this side must also be 120, okay? So just bring that value over. This side is 120. So we now have a triangle that looks like this, okay? The bottom is 90, the side right here is 120, and we're solving for that diagonal, it's unknown. Now we're gonna do step 2, label A, B, and C. C is the diagonal, the shorter one, the smaller number is A, and the leftover is B. Step 3, formula. A squared plus B squared equals C squared. The value of A is going to be 90, square it, plus the value of B is going to be 120, square it, equals the value of C is unknown, so I'm going to keep it as C, and I'm going to square it. So when I put this in Math Papa, it's going to give me C equals 150. That's 150 meters. Oops. So the corner, the distance from one corner of this soccer field to another is 150 meters. Cool. Last one, it's about a ramp. The bottom end of a ramp at a warehouse is 10 feet from the base of the main dock and is 11 feet long. How high is the dock? We're at a warehouse and we have a ramp. We're loading stuff up a dock. I'm gonna draw a dock. That's the dock. Then we have a ramp. That's my ramp. And there's the floor. Cool. You see a right triangle? I do. Let me highlight it for you. This is the right triangle right here. All right. So what do we know? We know 10 feet from the base of the main dock, 11 feet long. We're talking about a ramp. So the ramp is 10 feet from the base of the dock. So here's the dock, here's the beginning of the ramp. This distance here is 10 feet. How long is the ramp? The ramp is 11 feet long. So my triangle looks like this, 11, 10, unknown. How high is the dock? What's the vertical height of the dock? We don't know, that's my unknown. Step 2, label A, B, and C. C is my slant height. We can't be sure which one is smaller because we don't know this one yet, so it doesn't matter. Remember I told you A and B don't matter, just label it A and B. C is what matters, okay? So A squared plus B squared equals C squared, that's my formula. For A, it's unknown, A squared plus, for B, I'm gonna use 10 squared equals 11 squared. Put this equation in Math Papa. And you are going to get out a decimal. Let's round it to the hundredths place. That's going to give me 4.58. So A is approximately 4.58 feet. That's how high up the dock that ladder would reach if we place it 10 feet away from the base of the dock. Okay, so that's all for today. Again, if drawing the pictures is hard for you, just draw a right triangle and kind of intuitively figure out, you know, where what is. If it's a ladder, it's leaning, if something is leaning, that's the slant height, that's your C. If it's a wall or, you know, something going straight up and down, that's going to be your vertical distance. And if we're talking about the floor, that's the distance going straight across. Most of the time it's going to be the floor or the ground outside. If you have people traveling a certain distance, an airplane, that's north, south, west, and east, okay? So draw your pictures. Granted, you draw the pictures correctly, everything else should fall into place. Good luck on your assignment.